Hello students and YouTube learners. This is Dr. Satish Singhal, PhD, Professor Computer Science, El Camino College, Torrance, California. We are now on looping video 7, file reading, tokenizing, and parsing. And in this one, we'll give a foundation for a nested loop where outer loop is end of file control type loop. And inner loop in this case is sentinel control, but inner loop could be other type also depending upon the type of data. And outer loop is EOF controlled or end of file control because we may want to read and process multiple records from a file. This combination of nested loop where outer loop is end of file control type, it's a workhorse of software industry. You could be reading a file, database, or a web page. The outer loop will have same characteristic. In a database, you'll read records from a table until you reach the last record. In the file, you'll read with some reading strategy until you read the EOF character. And in the web page, same thing. You'll keep reading data from web page or from an XML page until you reach the last record or last piece of data. Okay, let's start. So we're covering some file reading strategies. This is not like comprehensive. There might be more. So one strategy is reading character by character, and we showed that in example in video number 4, looping video 4. Another very common example is reading token by token. Okay, so for that we need to understand what is a token. So what is a token? From point of view of computer programming, a token is a single character or multi-character piece of text or digits or punctuations. And we'll give an example of this very soon. Tokens can be space separated, comma separated, or separated by a specifying criteria. So let's see example of tokens. Let's say I have a phrase called "Give me liberty or give me death" by Patrick Henry. All words like give or me are all tokens. So in this case, we are not considering white space to be a token. And if I want to, I can take this comma also, consider that also as a token. So if I were to tokenize this phrase, one token will be this, 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 or that. Okay? Let's consider another example of a token. Let's say record in a professor's gradebook is such that there is a student, Joe Mann, who got 90, 86, 78, and 95 out of 100 score in 4 different tests. So in this one, Joe and Mann are name tokens, and numbers such as 90, 86, 78, 95 are test score tokens. So for example, you may want to process them a little bit differently. These tokens you might just read, store in some variables, and simply output to say hello. And these, even though you could output them literally, but you may want to sum them up, get the semester score, and there are 4 tests. You may want to divide the sum by 4 to get the average, and then assign a grade based on that. Okay? And we'll show examples of reading a file token by token and doing token processing very soon from this kind of record. And there are many other file reading strategy. You can read line by line. Entire line can be read into a string. And then you could tokenize. You can extract all the tokens from that string and process them. This is done, for example, when you are searching web pages for certain topic or certain word. You can store web page text line by line. And let's say you're looking for word computer. You can keep track of word computer, like how many times it occurred in a certain line. And then if you read 10 such pages, you can give some sort of page ranking depending upon how many times word computer was on that page. You could also read blocks of bytes and process them. And number of bytes read in each block may be constant, or you can vary them as per predetermined schemes. Okay. Lots of file reading strategies. We are just covering just a few of those. Okay. Another topic is sequential file reading versus random access reading. Files can be read sequentially, starting from a lower byte value, and you keep reading towards higher byte values. Reading is sequential in the sense that byte x plus 1 cannot be accessed or read without reading the byte x. Okay, so you start with byte number 1, then you read 2, 3, 4, 5. So you have to go in sequence. If you need to get to byte x plus 1, you still have to at least pass through or read all the bytes up to x. In this class, we'll only discuss sequential access. But there is another kind of access, random access reading. You can start reading at any byte number, and reading process can read any number of bytes in one access. In random access, reading one can read byte x plus 1 by jumping directly to that byte and skipping all the bytes from 1 to x. Okay. Now this you did in lab 4. Example of token by token reading of records. So in lab 4, this mechanism is often useful for either data processing on multiple records, where all records have the same structure, also same number of tokens. You have seen that in lab example 4, which you just submitted, where each employee had records such as first and last name, so name tokens, employee code token, employee ID number token, job classification token, number of years of service token, and educational code token. Now, in lab 4, each record had 7 tokens. This token were just read to say hello, and of course print that in the output table as name. This token employee code was used for determining the base salary plus also the employee title. ID was outputted as it is without any processing, and job classification, year of service, and education code were used to compute the salary. So one kind of file may be that all records have to have equal number of tokens. So if I had another employee, I'll have their first and last name, and I'll have their employee code, ID, job classification, years of service, and education code as well. And of course, in lab 4, you tested your data, your program, by entering data from the keyboard. But after this, you could do this after watching this video. You could do the same lab, number 4, typing all the data in the file and processing data by using a UF loop. So that would be another good exercise. Okay. Another example of reading token by token and data processing. Consider professor keeping record of students' first and last names and their scores out of 100 in various tests. But here we are going to throw in a number of tokens variation possibility, in the sense that we're not going to fix how many tests each student took. Maybe somebody took no test, somebody took 5 tests, or somebody took 4 tests. Okay, so what we mean is that all students may not have taken same number of tests, and some students may not have taken any tests at all. Data stored for such student in a file may look like next slide. And this type of file is the one that we're going to use in design example 5. Hopefully I can email everybody a copy today. Hopefully you can read it before next lecture. Okay, student test score records. Here there are variable number of tokens. It's not like lab 4 where number of tokens were fixed. So we have these records: John Doe 90, 80, 85, 87, and a -1. So let's explain. Mary Doe, Miss Genius. All records have first and last name tokens. Here, 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 here. And then John Doe took 4 tests, 1, 2, 3, 4. But Mary Doe took 5 tests, 1, 2, 3, 4, 5. So students need not have taken same number of tests. That's the other variability in number of tokens. And then last value in all records is a minus value. That means each record ends with a sentinel value or impossible value for the test score. So as you know, at El Camino, we don't give you negative grade as a test score. So negative value becomes a sentinel value. 0 will not be sentinel value because somebody could get a 0 in a test. Here we have shown gaps between the records because we wanted to put all these bubbles. But real file has no blank lines between records. 1 line, 2nd line, 3rd line, like that. Okay. Let's parse. Parsing means you are reading token by token, and then you're doing something with those tokens. So this is part 1 where we're showing you how to read and parse one type of record. So in this part, we discuss a strategy for a student who may have taken 1 or more tests. Here are our goals. Read first and last name tokens to say hello. So John Doe, so we're going to read these, store them into variables, and then say hello. You can think of variables to be first and last, string type. Then we sum up all test score tokens before the sentinel value. So if you are reading John Doe's test scores, 90, 80, 85, 87, so we just sum them up, and this is sentinel value, as you know from the central control loop, is always that exit the loop when you read this value. Okay. We also count number of tests. So we'll sum these up and we'll count there, like in this case, 4. And we find the average of all tests. That's easy. When I sum them up and I count there are 4, I can take the sum, divide by number of tests. Of course, you have to be careful about integer division. We'll talk about that in design example 5. And then assign the letter grade. We have done that several times, how to do that. So This part will be read score by score using a central control loop. Loop will sum up all the scores. It will count all the tests, how many tests were taken, and loop will exit when the sentinel value datum is read. Okay. The second one is that somebody may not have taken any test. In this one, we read first and last name, tokens to say hello. And since no tests were taken, there's only a sentinel value. We simply say you didn't take any test. So notice in this case, sentinel loop will not be entered because there are no test scores, basically. We'll show that very soon in the structure of a central control loop. Okay. An input file will have structure like below. John Doe took 4 tests, sentinel value. Mary Doe took 5 tests, sentinel value. Miss Genius took no test, so just a sentinel value. Willy-nilly has 4 tests, scores, and a sentinel value. And understand, I want you to get out of any dependency or making any assumption based on this data. So don't think that there will be 2 records first and then there will be sentinel Miss Genius record which has no test. It could be anywhere. It could be the first record. It could be the last record. Okay? And file may have only 4 records, only 1 record, only 1 record, or it could have 50,000 records. So you have to understand. Many times students just look at a file structure, they think whole program has to be made dependent on that structure. No, there are things. Okay, so here I have to say there's something called metadata. That remains the same. Actual data may vary. So what is the metadata here? Metadata here is that everybody has first and last name. So that part of the data about data is fixed. And everybody has a sentinel value. That's the second metadata. That is fixed. But other than that, nothing is fixed. Somebody might have taken 4 tests, 5, 4, and none. So I would like you to look at the file structures and understand the metadata and the data separate from each other. So basically there is no limitation of number of students record of any type. They may all have taken no test, all may have taken test, all may have taken different number of tests. And there is no fixed pattern of where is each type of record is located in the file. Any type of record may be located at any record number in the file. So here, this is record number 1, 2, 3, 4. But this may be located as record number 1 or last. So there's no dependency on the type we are showing here. And file may have just 1 record or any number of records. And there's no limit on maximum number of records. Okay? This is very important to see what is metadata and what is actual data. Okay, so let's look at this slide. Well, I had stepped away for a second, so you have some chance to look at it. Control structure summary to read file and process data. In this case, the student who took some tests. So that means the student record will look like this in the file. First name, last name, and number of scores, ending with a sentinel value. So we use nested loop. Outer loop is under file control loop. This has been explained in great depth in video number 4. And the inner loop, in this case, central control loop. This you're seeing for the first time. But I've given a nested loop example in video number 5 and 6. That's loop within loop. There Both loops were count control. But in nested loop, there is no limitation. Outer loop can be any type, inner loop could be any type, but they could both be same type, and the types could vary from one to the other. But one thing is certain, that when we read files, outer loop is always an UF control loop. Okay? And something similar will be done when you're reading data from databases or web pages. So meaning of this is keep reading the records from the file until UF character is read. So first we'll read first and last name tokens. So John and Doe will be read, and preferably they will be put into two different memory locations. And that would be used to say hello to them or print them in any shape or form. So I read up to here, then I read the token, which is the first test score. It could be 0, by the way. Okay, it doesn't have to be a value higher than 0. This is called prime read. We talked about prime read in the video on sentinel control loop. So this concept is very important. You need to understand when anybody says prime read, it should trigger in your mind right away what that is. So prime read is read into a variable called one score, and then we do this loop test that one score is greater than or equal to 0. If while it is greater than 0 or equal to 0, if this condition is true, then go inside the loop. Once again, why do we say equal 0? Because the student could get a 0 in a test. All right. So in this case, 90 greater than or equal to 0 is true. So we'll enter the loop and we'll declare some variable here somewhere, set that to 0, and we'll take the one score and add that to the sum. And same way, num test will be set to 0 here. And then we say num test equal to num test plus 1. That's because we read one score. We summed it up, we tested it, increased number of tests. And then we'll read next score or sentinel value. So as for this record, we read this one as a prime read. This will be read in first loop iteration, added to the sum. This will be read in the second loop iteration, added to the sum. Reading is done at this step. This will be read in the third loop iteration, added to the sum. Each time, num test increased by 1. So num test will eventually be 4. In this case, 1, 2, 3, 4. Okay. And finally, this step reads -1, a sentinel value. -1 greater than or equal to 0 is false. So you'll exit the loop. It's very important for you to understand the structure of this loop, how this works. And this picture will definitely help a lot. So you can pause the video here and look at it carefully. I will try to upload this PowerPoint also for your benefit. But it's extremely important to understand the structure of this loop. If you do not understand it, try it as many times as you can, because this is very, very important. Okay, so by the time this loop ends, I have the sum of all the test scores, and I have number of tests. So obviously dividing this by that, I can get the average, and then I can do the grade determination using the grade thresholds. That part is simple, so we're not going to worry too much about that right now, because we are focusing on the loop structure. And then you can print, grade, and other data. So that's for students who took one or more tests. Let's say student who didn't take any tests. Let's say their case. A student who took no test. So their record will be like this. Miss Genius -5. So same loop. In .peak not UF means keep reading the file until you read the UF character. So we read first and last name tokens. That could be done in 2 steps, preferably. And that's done to say hello to them. But this person took no test, so there's only one token, -5, which is read during the prime read into variable 1 score. But in this case, loop condition is false because -5 greater than or equal to 0 is false. So none of this is done. And num test was set to 0 here. So we just test that whether any tests were taken. If no tests were taken, then we print the message that no tests were taken. Okay, and that's the end of the UF loop. So this part will repeat for as many records like this. And if you go to previous video, this part from here to here will repeat for as many records that have at least one or more test scores. So this is very important to understand which part of code lines will execute for which records. This inner loop will always be entered as long as there is one or more test records. In case person didn't take any test, inner loop will not be entered. So those are the two different code structure situations which you need to remember when I go to discuss design example 5. All right. This whole technology that I showed you here will be discussed in tremendous depth in design example 5, which is next set of videos. Bye for now from video 7. There's an E missing, sorry. So this is Dr. Singhal saying goodbye from video number 7. See you soon in videos dedicated to design example 5.